everyone, I am Salma Manzanala and I'm going to discuss what is Q-meter. Anyone? Do you have any idea what is Q-meter? So, Q-meter is a design for measuring the Q factor of a coil and for measuring inductance, capacitance, and resistance of an electric circuit at radio frequency. Q-meter, it is also known as RLC meter. It was developed by William D. Laughlin in 1934 and it was developed in Bonton, New Jersey at Bonton Radio Corporation. We have here two actual example of Q-meter.
Application of Q-meter. The Q-meter can be used for many purposes. As the name implies, it can measure Q, and it's generally used to check the Q factor and indicator. Unknown independence may be measured using Q-meter either by series or shunt substitution method. If the impedance to be measured is small, the former is used, and it's large, the latter method. Capacitor sample resonated with a selected indicator by adjusting the source frequency and using the turning capacitor set to low value on its calibrated scale. Working principles. The operations of this useful laboratory instrument is based on the familiar characteristics of series resonance circuit, namely that the voltage across the coil or the capacitor is equal to the applied voltage to the Q of the circuit. If a fixed voltage is applied to the circuit, a voltmeter across the capacitor can be calibrated to read the Q directly.
Voltmeter 1 shows the source voltage E. Voltmeter 2 shows the voltage across variable capacitor. Indicator and resistor combined shows coils. Operations. First of all, the oscillator is set to desired frequency. Then the tuning capacitor is adjusted for maximum value under this condition. And if the voltage is kept constant, the voltmeter connected across the capacitor may be calibrated to read the value of the Q directly. This value of Q is commonly regarded as Q of the coil under test. There is an error. The measured value of Q is the Q of the whole circuit and not of the coil. Thus, the measured value of Q is smaller than the true value. Coils of high resistance are being measured. The difference between the two values may be negligible, but when measured are done low resistance coils, the error caused on his accounting may be serious.
Hello friends, in this video we are going to discuss the construction and working of Q-meter. So generally, Q-meter is an instrument which is designed for the measurement of Q factor of the coil, and also it measures the electrical properties of the coils like self-inductance, self-capacitance and resistance. Okay, so here we are having Q-meter which is used for measurement of Q factor. It is also known as a quality factor. Okay, and as well as resistance, inductance and capacitance of coil. Right? Next, here this instrument operates on the principle of series resonance. You might have studied the chapter resonance in the electrical network. Okay, so at resonance condition of an AC series circuit, voltage across the capacitor is equal to Q times of that of the applied voltage to the circuit. Okay, if voltage applied across the circuit is kept constant, then the voltmeter connected across the capacitor, okay, can be calibrated to indicate Q factor directly. Okay, so here at resonance frequency, we are having Vc is equal to Q into V in. V in is the input voltage. Okay, now here we are having the circuit diagram for the Q meter. Okay, so in this diagram we can see here we are having the oscillator, right? Next, across the oscillator we have connected the shunt resistance RSH. Voltage across the shunt resistance is measured by the voltmeter. That voltage is V in. Okay. Next, we are having the tuning capacitor C. Across the capacitor also we have connected the voltmeter, right? And the voltage across the capacitor is Vc. Next, between these two terminals, okay, we are required to connect the coil whose Q factor we are interested in finding. Okay, so here L is the inductance of the coil, resistance of the coil, that is the R coil, and CD is the distributed capacitance of the coil. Okay, so CD is the capacitance of the coil. Okay, and here C is the capacitor which we have connected, okay, in the circuit, right? So strictly speaking, here these are this one, right? Oscillator, shunt resistance and capacitor. Okay, these are the elements which are inbuilt in the meter, and whereas these are the terminals where we are going to connect the coil. Okay, so now we are going to discuss how it operates. Okay, so for carrying out the measurement, the unknown coil here we are going to connect. Okay, and the circuit is tuned either by varying the frequency of the oscillator or by varying the capacitor. Okay, next, readings of the voltage across shunt resistance RSH as well as voltage across the capacitor, means we need to take the readings of these two voltmeters. Okay, and at resonance frequency, yes, we know Vc is equal to directly Q into V in. Okay, so here we can write by definition of Q factor of coil. Okay, we are having Q is equal to XL by R or omega L by R. Okay, and at the resonance frequency we know, right, this expression, yes, it has been derived in the electrical network subject. Okay, next, at resonance we are having XL is equal to XC. So we can write Q is equal to XC by R, right? Because XL and XC both are same. So we can write Q is equal to XC by R. Okay. Next, VC. We know VC is equal to current in the circuit, that is the I into capacitive reactance XC. So we can write VC is equal to I into XC. I into XC. Okay. So what is the current I? Current I is nothing but the voltage V in, that is the input voltage, divided by the total impedance. Okay, into XC we can write, into XC we can write. Okay, so further we can write which is equal to V in divided by R into XC, because at resonance we are having impedance is equal to only resistance, because XC and XL both are same. And what is the Z? Z is equal to R plus J into XL minus XC. And at resonance these two are same, XL and XC. So their subtraction will be 0. Okay. So we will be having only resistance. So impedance is equal to only resistance. Okay. So we can write it as V in divided by R into XC. Right? Are you getting the point? So we can write it as is equal to XC by R into V in. Also XC is equal to XL we are having. So we can write which is equal to XL divided by R into V in, right? This is the VC we are having, right? This is nothing but the VC. So from this we can write, but what is the VC at resonance frequency? It is a Q into V in. So from this can we say Q is equal to XL by R, right? So therefore we can write Q is equal to XL by R, which is equal to XC by R, right? This is the Q factor, okay? Again, which is equal to VC by V in, which is equal to VC by V in, okay? So reading of the capacitor voltmeter across the capacitor divided by the input voltage V in, okay? So Q is equal to VC by V in, okay? Next, this Q factor is also called, this Q factor whatever we have derived, it is nothing but the Q factor of the circuit. Be careful, this is not the Q factor of the coil, okay? So this is the Q factor of the circuit, because this measurement includes the distributed capacitance of the coil and also the shunt resistance RSA, okay? So the calculated Q factor of the coil will be somewhat lesser than that of the actual Q factor, okay? So here this is nothing but the Q factor of the coil, Q factor of circuit, and Q factor of coil is somewhat lesser than that of this Q, or the Q of the circuit, right? But generally we consider this Q factor is nearly equal to the Q factor of the coil only, okay? So friends, this is about the Q meter construction and the working. Thank you.
So that's the end of the video. Now we will move on to the questions and answers, and then one sample problem which will be explained by Bea Quinto at the end. Number 1 question. Q meter operator is the principle of A. Series resonant, B. Current resonant, C. Self-inductance, D. Eddy currents. The answer is A. We all know that Q is equal to omega L over R, which from the above relation we can say that it works on a series resonance. Question number 2. Q meter is used to measure blank. A. The Q factor on the inductive coil, B. Only the effective resistance, C. Only the bandwidth, D. Q factor of an inductive coil, the effective resistance, and the bandwidth. The answer is D. Q meter can be measured the Q factor of an inductive coil. It can also measure the effective resistance. Also, the bandwidth can be measured by the Q meter. Therefore, it can be used for all of the above functions. Last question. The function of the Q meter is to measure blank. A. Measure capacitance, B. Measure inductance, C. Measure quality factor of the capacitor and inductor, D. Measure form factor of capacitor and inductor. The answer is C. Q meters are intended to measure the quality factor of a capacitor and inductor. They are not measured for measuring capacitance and inductance, unlike AC bridges.
So problem 1. A circuit consisting of a coil, a resistance, and a variable capacitor connected in series is tuned to resonance using a Q meter. If the frequency is 500 kHz, the resistance is 0.5 ohms, and the variable capacitor is set to 350 picofarad. Calculate the the effective inductance and resistance of a coil. The Q meter indicates 90. So let us first list down the given. So the first is the resistor, which is the resistance, which is 0.5 ohms. Next is the Q meter, which is 90, and the variable capacitor is 350. And the frequency is 500 kilohertz. So let us draw first the diagram. So we have here the So the formula for inductance L is equals to 1 over 4, So the formula for inductance is, inductance L is equals to 1 over 4 pi squared, and F naught squared C. To write this formula, because in the Q meter, the circuit is tuned to the resonance frequency. So the resonance frequency is equals to XL is equals to XC. So we know that the value of XC is equals to 1 over omega naught C, and the value of XL is equals to omega naught L. So the omega naught is equal to 2 pi F naught. So the XL and XC are equal. So we're going to put the value of omega naught and then equate the value of XL and XC. So we will get 2 pi F naught L is equals to 1 over 2 pi F naught C. So here we'll get the value of F naught is equals to 1 over 2 pi square root of LC. So through this equation, we can set the value of L is equals to 1 over 4 pi squared F naught squared C. So we are getting the value of inductance through the resonate frequency XL equals to XC. Here we are going to use this equation to find out the value of the inductance. So L is equals to 1 over 4 pi squared and times F naught squared C. So here is we will transpose this given. So L is equals to 1 over 4 times pi squared times 500 times 10 to the power of 3 times 350 times 10 to the power of negative 12. So the final answer is L is equals to 290 microhenry. So now we will get now the resistance of the coil. So effective resistance plus resistance. So R plus the value of resistance earlier is 0.5. So equals to omega naught L over Q. So the Q here is equals to omega L over R. So this R is the effective resistance. So we have here the equal is 2 pi F naught L over Q. So we will we will gamiton kami in order to para what do you call this, to put the given, para mabutang ang given. So r plus 0.5 is equals to 2 pi times 500 times 10 to the 10 cube. So why? Because it's f naught, ang frequency gina is pila to 500 kilohertz. So that's why nag-amon siya 5 kilohertz. So times 290, which is the 290, okay, here the L kanina. So times 290 times 10 to the negative 6 because it's microhenry over ang Q kanina, ang Q meter is 90, so 90. And then if we solve this tanan, amo siya ang magwa R is equals to 10.25 ohms. So kaya ginapangita ka is the effective resistance. We will transpose this 0.5 here. So R is equals to 10.25 ohms minus kaya transpose is equals to minus 0.5 ohms. So the effective resistance overall is to 9.75 ohms.